Hi, I am Krantiratan. Welcome to KR Educational Dunya. Here today we are going to see BTech or BE Basic Electrical and Electronics Engineering latest university question paper. Okay, we will see short questions as well as long question problems with explanation. This is the latest question paper, January 2025 university question paper, and which will be applicable for all years BEEE subject, basic electrical and electronics subject. First we are going to see short questions, which contains 10 short questions and 5 long questions of internal choice. Okay, in 5 long questions we'll be seeing about the problems. First question in part A, short questions, okay, which comes under DC circuits unit. What is practical voltage source and draw its VI characteristics? Practical voltage source, the definition for practical voltage source is the voltage source is dependent on the current, so then it is called practical voltage source. Here we are drawing a circuit that Vs is connected in series with the resistance RSC and the current flowing is Is, source current, and here coming to the VA characteristics. Okay, so in x-axis we are drawing current, in y-axis we are drawing V, voltage. Okay, here as the voltage is increasing gradually, as it is dependent on the current, so slowly in the x-axis the current is increasing, so the voltage line is depreciating slowly. This is the diagram of characteristics. And also Vt equal to, that is output terminal voltage, equal to source voltage minus drop. What is drop? Is into RSC. Next question. So in 1b, calculate the equivalent capacitance if 3 capacitors of resistance of capacitances 2, 4 and 8 microfarads are connected in series. So we have to calculate equivalent capacitance. Here when capacitances are connected in series, we need to put the formula 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So 1 by C1 value is 2 microfarads. So 1 by 2 plus 1 by 4 and plus 1 by 8. So at last we got 1 by C equivalent equal to 0.875 microfarads. So this is 1 by C equivalent. I need C equivalent value, that is total capacitance value. So C equivalent equal to 1 by 0.875. If you put 1 by 0.875, you are going to get 1.142 microfarads. So this is the answer. Next, part A 1C, which comes under AC circuits. Okay, so this question comes under the unit AC circuits. What is the average value of symmetrical waveform? Justify the answer. Here symmetrical waveform means positive waveform and negative waveform should be same, like square waveform, triangle waveform, which there should be a positive waveform and negative waveform. Both should be there with a symmetrical shape, then it is called symmetrical waveform. You can take any of the waveform. Here I have taken sinusoidal waveform. So I have taken sinusoidal waveform. So here they are asking average value of a sinusoidal waveform. So average value equal to the area under the total curve divided by the distance of the curve. This is the definition. So V average equal to 1 by T integral 0 to T V of T d omega T. From general solution we are writing this V average. After writing V average, if you find out, you are going to get V average equal to 2 Vm by pi, or you can take I average also. Okay, you can take any of the average value. So I average equal to 2 Im by pi. Either you can write like this or like this. Okay, next question D, okay, which comes under AC circuits. Define power factor. Define power factor. So power factor, there are so many definitions, you need to write everything. Okay, power factor, it is defined as the cosine of the angle of voltage and current. Cosine of the angle of voltage and current, it is denoted by cos phi. One definition. Another definition is, it is defined as the ratio of the resistance to the impedance, cos phi equal to R by Z. Or one more definition is there, it is defined as the ratio of the active power to the apparent power, that is cos phi equal to active power by apparent power. Active power formula is VA cos phi, apparent power formula is VA. So VA will get cancelled, again cos phi will be remaining. That is K, the units for active power is kW, the unit for apparent power is kVA. Like that you can write. Next question. What is step down transformer? Explain with example. Okay, step down, that means the voltage is getting stepped down, reducing, right? The transformer which reduces from higher voltage to lower voltage is called step down transformer. And example, 230 volts by 115 volts. If you observe carefully, the voltage is decreasing. Or 230 volts by 12 volts. If you observe carefully, the voltage is decreasing. So it is called step down transformer. Next question. Explain about dynamically induced EMF. Give an example. Okay. Here, according to Faraday's laws of magnetic induction, this question also comes under DC generators or DC machines. Okay. So in that unit, I am telling about the answer. According to the Faraday's laws of electromagnetic induction, when conductor is rotating and magnetic field is stationary, the resulting EMF is called dynamically induced EMF. Okay. Here you need to, if they ask about statically induced EMF, the conductor is stationary and magnetic field is rotating, then it is called static induced EMF. Okay. So they might be asking dynamically induced EMF or statically induced EMF. Okay. Next question. What is the principle of operation of diode? Diode operates on condition when the diode is forward biased. Diode does not operate, that is called off condition, when the diode is reverse biased. So we can call diode acts as a switch. Okay, when it is switched on, it is called forward bias. That means it is given forward bias. When the diode is reverse biased, it is called switch off mode. Next question. What are diffusion and transition capacitances of a diode? This comes under PN junction diodes unit. Okay, so what is transition capacitance? It is observed when the diode is in reverse bias condition. Okay, when the diode is in reverse bias condition, the forbidden layer, okay, or the depletion region layer, it acts as a capacitive, it behaves as a capacitance. So that capacitance behavior is called transition capacitance. And diffusion capacitance. Diffusion capacitance means it is observed that when the diode is forward biased, okay, then it is called diffusion capacitance. The behavior at the depletion region or forbidden region is that capacitance behavior is called diffusion capacitance. Okay, next question. Why transistor is also called bipolar junction transistor? Okay, this is comes under transistors unit. Okay, there is a transistors unit, so or BJT unit, this comes under transistors unit. Okay, so the diagram I am drawing here, emitter, base, collector. Okay, it is NPN transistor, and if we observe carefully, there are two junction points here, junction 1, junction 2, and the connections which we are giving emitter, base, collector for a PN junction diode. And here they are asking why transistor is called bipolar junction transistor. Bipolar means the NPN and PNP transistors consisting of two junctions. and two charge carriers, majority carriers and minority carriers. So it is called bipolar junction transistors. That means here in BJT, in transistors, we will be considering minority carriers as well as majority carriers. That's why it is called a bipolar junction transistor. Next question. State the three operating regions of transistor. Okay, this is also comes under transistors unit or BJT unit. The three operating regions are active region, saturation region and cutoff region. Active region means in junction 1 it is forward bias, junction 2 it is reverse bias. Saturation region means both the junctions are forward bias. Cutoff regions means both the junctions are reverse biased. Here I have given forward bias, but both the junctions are reverse biased. Ikkada R. Okay, cutoff region, both the junctions are reverse biased. Next, now we are coming to the part B, which comes under 5 marks questions. Okay, here we are seeing only problems. So here 2B, determine the current flowing in the 50 ohms resistor using mesh analysis. So when they are giving mesh analysis, we have to apply only mesh analysis only or KVL, but we should not apply nodal analysis. Okay, then they won't consider. So mesh analysis, here if you observe carefully, there are 3 internal loops. Okay, one internal loop, second internal loop and third internal loop, and I am naming it as I1, I2 and I3 in clockwise direction. There are many methods, and this comes under DC circuits unit. Okay, so for the first unit, circuit, we are applying KVL for the loop 1, that is A, C, B, A. Wherever you are starting, that should be ending. Okay, for the loop 1 A, C, B, A, I am writing the loop equation. So I am starting from A minus 50, I1 minus 10, here minus 10, I1 minus I2 minus 15, I1 minus I3 is equal to 0. This is the first loop equation. So after doing that, we have to write in terms of I1, I2, I3 equal to constant. That form we have to write. Okay, after that I am applying KVL for the mesh B, C, D, B. So from B I am starting. So minus, wherever the resistance is there, we are starting from minus, ending point, plus minus. So I am taking ending point. So minus 10, I2. Now the I2 loop we are writing. So I2 is the main current. So minus 10, I2 minus I1, again minus 25, I2 minus I1, again minus 30, I2 minus I3 is equal to 0. So this is third equation. So from this we have to solve the equation, and we have to write in the form of I1, I2, I3 equal to constant. That form you have to write properly. Okay, next applying KVL for the loop A, B, D, A. Okay, that is the inner loop. We should not take A, C, D, A, because that is outer loop. So inner loop you have to take. So from A I am starting. So minus 15. Now the main current is I3. So I3 minus I1. There are two currents flowing in this 15 ohms. So minus 15, I3 minus I1, and again minus 30, I3 minus I2. Again here there is a supply, and here the starting point is minus. Okay, so here we have to take so everywhere we are taking plus minus. So here also we have to take ending point. So plus 24. Okay, there are many methods for doing KV mesh analysis. Okay, this is one of the method. So plus 24 is equal to 0. Third equation. So write the equation in terms of I1, I2, I3 equal to constant. After getting that, if you put the three equations in the calculator, you will be directly getting I1 value, I2 value, I3 value. So I1 equals 0.247, I2 equal to 0.467 and also I3 equal to 0.926 amps. So they are asking current flowing in 50 ohms resistor. So what current is flowing in 50 ohms resistor? Only I1 current. So the I1 equal to 0.247 amps. This is the answer. Coming to the next problem, that is 3b. Here they have given nodal analysis. Okay, this also comes under DC circuits nodal analysis topic. So here determine 3b, determine the node voltages V1 and V2 by applying nodal analysis. Just they are asking at 1 and 2 nodal voltages. So write down the equation, and considering at node 1 the higher potential voltage is V1 and at node 2 the higher potential voltage is V2, and if you observe there are totally 3 nodes, V1 that is 1, V2 that is 2, and another node is, if you join all the down points, that is all the down branches at one point, that will become a node. Okay, so we have to consider there are 3 nodes. What do you mean by node? Where 3 or more branches meet is called a node. So here we are having totally 3 nodes, V1, V2 and also the down one where everything got met at one point. Okay, so 3 nodes. So one node, that is ground node, will be considering as reference node, that is V reference equal to 0 volts, and our remaining nodes we need to find out. So there are 2 unknown nodes, V1 and V2. So we are finding at V1. So think that V1 is having highest potential. So from V1 I am writing a KCL. What do you mean by nodal analysis? Nodal analysis means KCL plus Ohm's law. Okay, KCL means I1 plus I2 plus I3 equal to 0, right? So here I1 means the current flowing from this line, and I2 is the current flowing from this line, and I3 is the current flowing from V1 to V2. Okay, so first I1 value we are finding, that is I don't know I1, so I am writing in terms of V by I equal to V by R. So V by R form. So here I am writing, so V1, as the current is flowing reverse, V1 minus 10 by 2, that is V by R form. Next plus I1 plus I2 plus I3, right? So I1 I have written, after that I am putting plus, after that V2, I2 means V1 by 4, because that means V1 minus 0, one node to another node, so V1 by 4 plus the I3 means V1 minus V2 by 2.5 is equal to 0. So this is the nodal analysis, right? And after that make it as V1, V2 and equal to constant. Okay, we have to write in this form. Okay, after doing that, next go to the next node, that is V2 node. So here think that V2 is having highest potential, and here there are 3, that is I4 plus I5 plus I6 is equal to 0. Now I am telling about the I4. I4 means, according to Ohm's law, I4 means from here to here. So V2 is the highest potential. So V2 minus V1 by 2.5 is the I4 value. Next I5 value is V2 by 5. Next I3 value is V2 minus 4 by 1 is equal to 0. This is the nodal analysis equation. So here again solve this, and we have to get in terms of V1, V2 and equal to constant. We have to write in this form for putting the 2 equations. See, there are 2 unknowns and we are having 2 equations. So can we solve the problem? Yes. So put these 2 equations in calculator, you will be directly getting V1 value and V2 value. So V1 equal to 5.714 volts and V2 equal to 3.928 volts. This is what they are asking. Determine the node voltages V1 and V2. So we have found the node voltages. Next, coming to the another question, and this question you will find in AC circuits. Okay, in AC circuits 4B. is the problem. So read the problem carefully. If the applied voltage, so here the AC voltage is 230 volts and the frequency is 50 Hz in a series circuit. So what is a series circuit? There is a resistance and there is a capacitance. So both we have to connect in series with the voltage. So resistance is having 20 ohms and the capacitive reactance, they didn't give capacitance value, they have directly given XC value, capacitive reactance value, that is in terms of 200 ohms. And find the magnitude of the current and phase angle. Magnitude means value. So here R equal to 20 ohms, a capacitive reactance equal to 200 ohms, and the voltage equal to 230 volts, and frequency equal to 50 Hz. And they are asking us to find out current value and also phase angle phi value. So current I equal to, we need to find. For finding current, the formula is I equal to V by Z. I know V value but I don't know Z value. So find out Z value first. So Z equal to under root R square plus XC square. R square is 20 square and XC square is 200 square. So you got Z value as 200.249 ohms. So current I equal to V equal to 230 volts. So 230 by 200.249, 1.148 amps. Always it is better to take 3 digits after decimal. Okay, then you are going to get correct values. And next after that, phase angle phi. The formula for phase angle for a capacitive circuit is tan inverse minus XC by R. So tan inverse minus XC by 200 by XC value is 200 and R value is 20. So tan inverse minus 200 by 20. Here if you have to observe, if there is minus value, you can put minus after getting the solution also. So you can take in the calci tan inverse 200 by 20, after getting the answer you can put minus. Okay, now you got 84 degrees and 0.289 minutes. This is the phase angle. Always phase angle you have to write in terms of degrees and minutes. Next question. A resistance of 100 ohms. This question is also comes under AC circuits only. A resistance of 100 ohms, an inductive reactance of 60 ohms and a capacitive reactance of 5 ohms are connected in series with each other across a supply of 200 volts. Calculate impedance, power consumed, power factor and draw the phasor diagram. So here resistance value is 100 ohms, and here also they didn't have given inductance value, they have given inductive reactance value. So inductive reactance value is XL equal to 60 ohms, and they didn't have given capacitance value, they have given capacitive reactance value. So XC equal to 5 ohms and the voltage that is given in series connection is 200 volts. So here also I need to know impedance Z. First impedance Z I need to find out. Impedance Z equal to root R square plus XL minus XC. Here we need to observe which one is greater. If XL is greater, then XL minus XC square. If XC is greater, XC minus XL you have to write, right? So if XL is greater, that is a inductive circuit. The power factor is inductive in nature. If XC is greater, the power factor is capacitive in nature. Okay, that is leading. Okay, if it is capacitive, leading. If it is inductive, lagging. So you need to observe this. So here XL value is greater, so you have to put the formula root R square plus XL minus XC whole square. So after doing that, you are going to get 114.127 ohms. After that, power consumed. Okay, they are asking power consumed. So power consumed formula P equal to VI cos phi. V value 200 and I value is you don't know I value, so I equal to V by Z. So you can put V 200 by Z. Z value already you found, that is 114.127 into cos phi value. So here you know phi value. Okay, what is the phi value? Phi value is 0.8. Phi value is 0.876 lagging. Why? Because phi value means the current is lagging, so of 0.8. So cos phi equal to cos phi, so cos into phi angle is 0.876. So phi, how you are going to find out the phi value? Just by putting tan inverse XL by R. Okay, so if you put tan inverse XL by R, you are going to get phi value. Okay, next, so VI cos phi 350.44 watts. Don't forget to put units. Okay, it will be in watts. Power means watts. Next, power factor cos phi equal to phi equal to tan inverse XL by R you can take, or directly you can take cos phi value also. Cos phi value means the formula in the short answers you have seen the formula R by Z, right? So 100 by Z value is 114.127. So cos phi value is 0.876. So you should not put cos 0.876, directly you can put into 0.876. Okay, so cos phi equals 0.876 you got. So here you should not put cos, this is not angle value, this is cos phi value. So put here directly into, in power consumed you have to put into 0.876, that is enough. Okay, and after that in the graph, if you observe carefully, so they have asked phasor diagram. So in the phasor diagram I have taken I current as reference, and current lags voltage by 90 degrees for an inductive circuit. So current is lagging, so VL comes at the as y-axis, okay, positive y-axis, and current leads voltage for capacitive circuit. So you are getting in down arrow as VC. So in this, if you observe carefully, VL value is greater, XL value is greater than XC, right? So VL value is greater than VC value. So you are going to get VL minus VC at this point. So for this VL minus VC and VR, if you take a resultant value, then you are going to get vector V. Okay, so this is the phasor diagram representation. And coming to the next question, 6B is a problem. Okay, this comes under transformers unit. Okay, a single phase transformer of 2000 volts, 250 volts, bar 250 volts. Here if they give 2000 bar 250, that means E1 is the 2000 volts and E2 is 250 volts, primary and secondary, and 50 Hz, frequency is 50 Hz, has the net core area, A value they have given, net core area is 36 centimeters square. Okay, while taking itself we have to convert into meter square, because we are taking all the values in meters, right? So 36 centimeters square into 10 power minus 2 whole square, that is 10 power minus 4. Okay, 36 into 10 power minus 4 is the area in meter square. Okay, after that maximum flux density B, the symbol is B, is 8 Webers per meter square. Here they have given in meters only, so 8 Webers per meter square. And determine the number of turns in primary and secondary windings. So here we know the regular formula, that is EMF equation of a transformer, referred to primary E1 equal to 4.44 N1 F phi m. Here they have not given phi m value. Instead of phi m, the formula for phi m is Bm into A. So we are writing directly 4.44 into N1 into F into Bm into A. So here what I need, N1 value, remaining I know the values, right? So N1 equal to E1 by 4.44 into F into Bm into A. Okay, so substituting all the values, you are going to get 312.812. Always N1 means number of turns in primary, number of turnings. So 1 turn, 2 turns, it will be like that. So you should not write in decimals. So you have to take a round figure as 313. Okay, N1 is approximately equal to 313 turns. Okay, coming to the N2, you can take a transformation ratio formula, or you can use directly EMF equation formula. Okay, so N2 equal to E2 by 4.44 into F into Bm into A. So for 250 by remaining things, if you put, you are going to get 39.101. So here also N2 value approximately you have to take a round figure, you should not take decimals value. So we are considering as 40 turns. N2 is 40 turns. Okay, this is how you have to do the problem for single phase transformer. And coming to the 11B question. Okay, 11B, which comes under transistors unit. Okay, 11B, if the base current in a transistor is 20 microamps, when the emitter current is 6.4 milliamps, what are the values of alpha and beta? Also calculate the collector current. Okay, IC also they are asking. So what we need to find out first? We need to find out IC value, we need to find out alpha value, we need to find out beta value. And what is the given data they have given? IB value, base current IB equal to 20 microamps, emitter current IE equal to 6.4 milliamps. So to calculate collector current, we know the formula IE equal to IB plus IC, right? In that unknown value is IC. So IC equal to IE minus IB, and substitute those values. Don't forget to put proper things, that is micro means 10 power minus 6 and milli means 10 power minus 3. So substitute that, you are going to get IC value. So here IC value equal to 6.38 in milliamps, that is 10 power 3 amps, 10 power minus 3 amps. Okay, next alpha equal to, we know the formula del IC by del IE. So delta IC value is, that is delta IC means IC value only. So delta IC value is 6.38 into 10 power minus 3. Alage delta IE is 6.4 into 10 power minus 3. If you substitute those two, you are going to get alpha value, that is 0.996. Okay, we know alpha beta relation, right? So beta equal to alpha by 1 minus alpha. So substitute those values, 0.996 by 1 minus 0.996, you are going to get 249. Beta value is 249. Okay, next question. Okay, we have finished all the problems regarding new question paper, and don't miss out, like, share and subscribe to our channel and keep following. And if you go to the playlist, you'll see so many things, and also if you observe carefully, you'll see a lot of lab experiments done practically with explanation. Okay, thank you very much.